So what is the nature of truth? What if there was a completely different way to think about truth? A way to rethink the relationship between ourselves, our words, and the world around us, right? What if there was a way to do this? What does it really mean when we say something is true? That's the question I'm going to tackle with this PowerPoint presentation. I'm going to go over how the concept of truth is currently understood, kind of in a basic way. I'm then going to introduce a different way to think about truth. Then I'm going to explain how this concept can be mathematically described. Finally, I'm going to give my answer, what I found that answers the question, what is the nature of truth? So truth, as it's currently defined, is considered as that which is true or in accordance with fact or reality. It's also defined as a fact or belief that's accepted as true, or a proposition that agrees with facts. There are some problems with these definitions. Truth is often used to describe itself, or it's described in terms of fact or reality, and these terms themselves are not really well defined. Truth usually involves some kind of statement, a statement that's either true or that's false. And how it's used normally, we have a statement like the apple is red. That statement is true if it refers to, in reality, an apple that is in fact red. The statement is false if it refers to an apple that isn't red, maybe a green apple. In the same kind of way, if you ask the question, where is the store? If you get an answer 1 block north, that answer is true if, in reality, there is a store that's in fact 1 block north, right? The answer is false if there's a store that's 1 block east. Truth has to do with the relationship between statements and the real world and reality. The store is 1 block north is true if there is a store that's actually 1 block north. Truth can be defined in an intuitive way as a statement in accordance with reality or in correspondence with reality. This is the sort of oldest conception of truth, known as the correspondence theory. The scientific paradigm of truth that's very successful is thinking about observations agreeing with or disagreeing with a hypothesis, which is a provable statement about the world. So you might have a hypothesis, which is the store is 1 block north, and you might make an observation that the store is in fact 1 block north. In this case, your observation agrees with your statement or your hypothesis, so you have evidence to prove that statement is true. But what if there was a completely different way to think about this problem entirely? Think about what happens instead when the information is actually used. So imagine you have Kate and you have Jim here. So Jim wants to know where the store is. Imagine in scenario 1, Kate says the store is 1 block north. This happens to be true. So Jim, he says thanks, and he makes his way directly to the store. Imagine another scenario where instead Kate says the store is 1 block south. This happens to be false. Jim says thanks, and this time, instead of making his way directly to the store, he goes the wrong direction. So he has to stop, he has to turn around before he can find the store. So when Jim uses the true information to get to the store, he goes to the store directly, and he finds the store very easily. On the other hand, when Jim uses the false information to get to the store, he has to turn around, right? It's harder for him to find the store. So there's this relationship here between something being true and something being easier, and something being false and something taking more work or being harder. So can truth be defined as a statement that makes doing something in the real world easier? That seems to be getting towards a more concrete definition of what truth is. So imagine again, you have Kate and Jim, right? What she says is true, so Jim makes it to the store easily. There's a relationship between her true statement and his easy action. Now, her false statement leads to a harder time for Jim. He has to turn around before he gets to the store. It's hard for him to find the store because what she said was false. So how can we measure easier in an objective way? What does easier mean? We can think about easier as something taking less energy, right? If something's easier, it takes less energy to do. So now there's a relationship between truth and energy use, right? Let's see if this makes sense. So something true might be something that saves energy, right? It's like a green battery. It's information that kind of gives you more energy. Something false might be something that wastes energy. It's like a big red battery, right? It takes away your energy. Energy is kind of like capacity to do work. That's actually the formal physics definition. So saving energy is just like saving work. So energy is roughly equivalent in everyday life and actually in formal physics to work. Something true, therefore, means you can do something with less work, right? Something false means it takes more work to do something. There's this relationship between truth, energy, and work. And now let's see if this makes sense. Instead of thinking of truth in terms of statements that are true or false, think instead in terms of statements that either save energy or waste energy. Now imagine Kate again. When she tells Jim the store is 1 block north, that statement is actually an energy-saving statement for Jim. He says thanks. He's able to get to the store very easily, right? It takes him less work. When she says the store is 1 block south, it's the false statement, but it's an energy sapping, it's an energy wasting statement for Jim. He can't find the store easily. He has to turn around. It takes him more energy to find the store. It takes him more work. So can truth be defined then as a statement that helps you save energy or save work? This might be getting even closer to a kind of formal definition. Consider now, instead, a different example, a padlock. Let's see if everything we've done agrees. So what is the true combination to a padlock and why? The true combination, very intuitively, just on a first order basis, is the number that allows you to open the padlock. The true combination makes opening the padlock easy, right? The false combination makes opening the padlock more difficult. In the same way, there's this relationship between truth and energy use. So the true combination saves you energy when you open the padlock. It takes less work. You plug in the numbers and you open it right away. If you have a false combination, you can't open the padlock. You enter the combination and it doesn't open. You waste your energy opening the padlock. It takes you more work to do. So a combination is true because it saves you energy. Now consider this. A padlock combination isn't actually language. So how do we integrate something that's not language into our thinking and into our definition? We have to go beyond language. What's more general than language? Information, right? Information is any kind of arrangement or sequence of things that conveys meaning in some way. So information can be anything from your senses, anything you see or hear, your touch, smell, or taste. It can also be any kind of language. Language itself is a kind of information, right? Any kind of language is a part of information. It can also be any kind of set of symbols, any kind of numbers, any kind of letters. So truth, instead of being a statement that's true or false, may instead be information that saves energy or wastes energy, right? This is a more general form of the same concept. Instead of being language, it's information. Instead of being true, it's energy saving. Instead of being false, it's energy wasting. So is truth really a language concept? Is it really a philosophy concept involving propositions and facts? Or is it instead a physics concept? Is truth really physics? Because truth involves physics principles, information, and energy. So let's go with this new paradigm, this new framework for thinking about what truth is. So when you're asking, what is the true lock combination? It's just like asking, what is information that will reduce the energy I need to open the lock? This is also just like asking, what is information that will allow me to use my energy more effectively? So we come to yet another definition of truth. Maybe truth is the property of information that is able to increase how effectively energy is used. Now we're getting somewhere. Now we're getting to something much more concrete. We're tying truth to a fundamental property of reality, so which is pretty cool. So more effective energy use, right? That means practically, what does that mean in practical terms? It means you're doing less work per task. True directions, right, are information that reduce the work needed to complete the task of navigation. A true padlock combination is, in the same way, information that reduces the work needed to complete the task of opening the padlock. Right? So the true padlock combination saves you work, right? You open the lock right away. The false padlock combination, on the other hand, right? Imagine this, you're given the false padlock combination, you still have to open the lock, so you spend however much time guessing the answer to the combination. You're guessing for hours and hours. You're putting in hundreds of different combinations. The false padlock combination wastes tons of work. So truth can actually be generalized at an even deeper level. It can be generalized even more. How? The concept of information itself can be further generalized. So consider information in the most general possible way. Information, like whether it be electronic symbols, whether it be, sound waves, whether it be writing. What's a universal characteristic of all information? All information has to have some sort of structure, right, in order to convey meaning. Random lines, like just squiggles on a piece of paper, don't have any structure. Therefore, they can't really mean anything. They can't really hold any meaningful information. Structured lines, on the other hand, right? Structured lines can have meaning, can hold information because of their structure, because they're organized in a specific way that's already defined in some meaningful way. So more structure is a lot like saying more order, more organization, right? Less randomness, less disorganization, more order, more predictability. When you get these orderly, predictable structures that are already defined, they have meaning, they have information. So order is very closely related to an existing physics concept called entropy. Entropy is defined as a lack of order or predictability, or a gradual decline into disorder. More entropy means less order. Less entropy means more order. You can see here, on the left, you have two rows of balls that are very ordered. They're very structured. They therefore have low entropy, right? As you go from the left to the right, you're getting sets of balls which are more random, more chaotic. They are higher entropy because they're no longer in organized rows. They're now randomly distributed. In the same exact way, a closet that's neatly organized and neatly folded, with neatly folded clothes, is very ordered. It has very low entropy. Whereas a big messy closet, a big messy dresser, has a very high entropy. It's very uncertain. It's very disordered and unpredictable. Information must be ordered because it has to be in order to hold meaning, in order to make sense. Therefore, information has to have low entropy. These things must be related. Because if information was totally chaotic, right, it wouldn't actually mean anything. Entropy is also closely related to uncertainty. Think about if you had a very, very clean room, right, where everything's organized, you would be very certain as to where everything was. You would know exactly where your jeans were. You'd know exactly where your shirts were. On the other hand, if your room was a total chaotic mess, you would have no idea where to find your clothes. You'd be very uncertain. So high entropy is like high uncertainty. Low entropy is like a very low uncertainty. Truth is kind of like, with this even more generalized concept of information. It's kind of like a low entropy or set of information or set increased certainty that is able to save you energy. It's like low entropy that saves energy, right? Truth is related to these things. So what should we see if this is correct, if this way of looking at truth makes sense? We should see, as you go from less truth to more truth, you should actually see when you have less truth, you have more uncertainty. You're less certain. You should also see higher entropy or more disorganization. As you go towards more truth, right, you have less uncertainty. You have lower entropy. You have more order, right? You should also see, and this is also very important, when you have less truth, you have low effectiveness. You're doing a high amount of work per task. When you have more truth, on the other hand, you have a very high effectiveness. You're doing a low amount of work per task. So these things, if this way of looking at truth makes sense, should all go in tandem with each other. When you have more truth, you're very certain and you're doing a very low amount of work per task. So now let's analyze the lot combination, because the lot combination is our basic framework for truth as information. So what does it mean to have no truth with the lot combination? That would be like knowing none of the digits. Having a lot of truth would be like knowing all of the digits. So that's like going from less truth to more truth is like learning more digits to your lot combination. So let's now think about certainty. So when you have less truth, when you know none of the digits of the combination, it's very uncertain. If you have 4 digits, the combination could be any one of 10,000 different numbers. On the other hand, if you know, for example, 3 of the digits and you don't know one of the digits, right, the combination is reduced to only 1 in any of 10 numbers because you're only uncertain about 1 digit. So as you learn more true digits of the combination, your uncertainty about what the true combination is decreases. So you're going from more uncertainty to less uncertainty, or you're becoming more certain. Now let's look at energy use, right? When you're very uncertain about the lot combination, so when you're very uncertain about the lot combination, you have to guess a lot of possible choices. You use a lot of energy to open the lock. On the other hand, imagine that you know all of the digits of the lock combination. You know the entire combination. You can open the lock on the first try. You spend very little of your energy. You do a very small amount of work opening this lock because you're very certain about what the combination is. And as you know more digits, you get more certain, and it takes you less energy to open this lock. And this shows how as you get more truth, you get more certain, and you also get more effective at opening the lock. So the lock combination shows all of these predicted characteristics of truth. As more true digits are known, the uncertainty decreases, effectiveness increases, the amount of work you're doing per task goes down. So is truth related to technological progress? As you can see, it's directly related, because as we learn more truth about our world, everything around us becomes less uncertain. It becomes much more predictable, right? Because of this, we're able to make more complex technologies. And these technologies, in turn, make us more effective, make tasks take less energy. So imagine less truth. Maybe in the distant past, we knew less truth about the world, right? So we could only make very simple technologies. The world was very unpredictable. But as we get more truth, right? Look at what happens. Our technologies have gotten more complex. Our world has become much more certain. We've gone from a very sort of low complexity where we had spears and bow and arrows that maybe had 2, 3, or 4 components, to now with modern technology we have cars and we have computers that have millions of components or thousands of components that all have to be precision made. So this shows actually how we've gone from very low complexity to very high complexity as technological progress has gone, as we learn more real truth about the world. Also, think about how our effectiveness has increased. When hundreds of years ago, when we had very simple technologies, the amount of work we had to do per task was much greater. In order to mill corn, we had to mill it by hand, or we had to use draft animals. It took a long time. Now with modern technology, it takes us much less work to do each task we have to do, especially in terms of transportation. To get around the world hundreds of years ago, it took months. It was, a very dangerous endeavor. It took sailing a ship across the ocean. Now, with modern technology, we can step into an airplane and be around the world in a few hours. That's a very small amount of work for the same task. Truth is tied to physics. So can it be mathematically described? It actually can. Let's see. Truth is related to energy that's saved from information. So the relevant question, the thing we want to know about truth, is how much energy does this information save me? Truth is like, when you want to know about truth, you want to know how much energy do I get per this new information I have. That's what's important to know about truth. The same thing can kind of be described as, what is the change in energy per the change in entropy or the change in information? Truth is therefore describable as the delta function. It means change, so it's describable as change in energy per change in order or change in entropy. This gives us the truth equation. So the truth equation is a mathematical way to encapsulate what truth actually is. The change in truth is equal to the change in energy per change in entropy. right? A mathematical description for truth. So the change in truth is the change in energy per change in entropy. This can be most easily described as the difference between the start energy and end energy, and the difference between the beginning probability and end probability, right? That's the simplest way to really encapsulate what this is that can be used in a practical example. And additionally, this equation can be normalized. All you do is divide the energy by the start energy and probability by the start probability, so it's proportional instead of direct. It cancels out the units and it makes everything simpler. So we're going to describe now an example of how to use the truth equation using our trusty lock combination. This is going to show the difference between knowing no true digits of the lock combination versus knowing one true digit of the lock combination. Imagine if you know 0 digits versus if you know the first digit is 9. Now remember from before, when you know 0 digits, it's very uncertain. There could be 10,000 possible combination digits. It takes you a ton of energy to open the lock. It takes you actually about 415 watt-hours of time spent guessing what this lock combination what the lock combination is. If you know, on the other hand, if you know the first digit is 9, right, there are only 1,000 possible remaining digits, right? So it takes you 1/10 the amount of energy to guess what the lock combination is. It takes you only 41.5 watt-hours to guess the combination if you know the first digit is 9. So the change in energy per change in entropy. You have the start energy, which is 415 watt-hours, minus the end energy, which is 41.5 watt-hours. And you divide that by the end energy, which is 41.5 watt-hours. Now, because the ratios are 1 to 10, this gives you a value of 9. And you multiply this by the end probability, which is 1 in 1,000. You subtract that from 1 in 10,000, and you divide that by the beginning probability, which is 1 in 10,000. This gives you 9 times 1 over 9, which is equal to 1. What does this actually mean? This means that the information that you get, that the first digit is 9, saves energy in the same proportion that it reduces your uncertainty. So what does the truth equation suggest about what truth actually is? It suggests that truth is energy saving order, right? It suggests something even more general. It suggests that truth is actually deeply tied to what the universe actually is, because energy and entropy are fundamental real properties of reality itself. And it's actually fundamentally tied to creation, to the emergence of states of order or states of complexity from reality itself. Right? So truth is actually tied to the universe. It's tied to creation. What does it mean to pursue truth, to find more truth? What does that actually mean according to this way of looking at it? It means you're trying to optimize your information and trying to optimize your energy use, right? You're finding more truth. It means you're saying more. You're saying more important things with less information. And it also means you're doing more. You're accomplishing more with less energy. You're becoming more effective, and you're saying less, but you're meaning more. Because everything in the entire universe, right, involves energy, involves information. Truth is related to everything in the universe. Everything can be described in these terms, in terms of energy, in terms of information, right? And consider this, truth is actually, already well beyond language, right? Truth is even beyond information, right? Truth is actually tied into the very structure of reality itself, right? So truth isn't just a statement about a flower. It isn't just the flower is blue. It isn't just information about a flower. Like the flower has 6 petals, right? The flower itself is true. The very flower itself. So what is the nature of truth? What is the actual answer to the nature of truth? Truth is energetically favorable states of order. That's the nature of truth. So, the flower has 6 petals, right? Is an energetically favorable state of ordered symbols, right? Because it corresponds with the flower that exists in reality, in the real world. The flower itself is an energetically favorable ordered structure, right? It's energetically favorable, or it wouldn't exist, because it attracts the aids of insects for reproduction. It helps the flower to reproduce. It helps the plant. So the flower itself is true. Truth, right, described in this way, encapsulates the very structure and order of the reality we see around us itself. The very flower that exists in the world is truth, right? It goes well beyond language, and that's the answer that I reached for what is the nature of truth and why.